Hey guys, welcome to Dramatic Science. Me, Ayan. Today is the first lecture of the topic work, energy and power. So let's see what will be our topic of discussions today. So these four will be discussed today. Number one is work done, its concept, definition and unit. Then types of work, then no workforce, basically the definition of no workforce, and fourth is power, similarly its definition and unit. So these four are today's topic. Let's start with the first topic, that is concept of work done. So our first topic is concept and measurement of work. Suppose we are considering a block on a surface of mass m. We are applying certain amount force, say capital F, and after a small amount of time the body displaces to a position like this. S be the displacement. So this one is the initial position of the body small m, and this one is the final position of the body. How it displaces? It displaces by applying a force capital F. So we can say applied force is F and displacement of the body as S. So this incident is work or work done. So work done relates basically the movement or the change of position of a body due to an applied force, right? How we can measure this? Therefore, work done or simply work, W equals to, its formula is force into displacement, that is W equals to Fs. This is the expression of work done, that is force into displacement. So what will be its unit? Units in SI process. So for SI process we need to know the unit of force F, that is Newton, and S, that is displacement, meter. This is called joule, capital J. And in CGS, Newton will be replaced by dyne and meter will be replaced by centimeter. This is called erg, E-R-G, right? So how we can define 1 joule? 1 joule is that amount of work by which a body displaces by 1 meter due to an applied force of 1 Newton, right? That means if we apply 1 Newton force to a body and if the body displaces by 1 meter, then we will say the work done on the body is 1 joule, right? How we can define the relation between joule and erg? Simply do a ratio, 1 joule by 1 erg. 1 joule is 1 Newton into meter and 1 erg is 1 dyne into centimeter, right? So Newton and dyne का relation क्या है? What is the relation between Newton and dyne? 10 to the power 5 dyne. Basically 1 Newton equals to 10 to the power 5 dyne, right? And here it is meter, this will be 10 square centimeter, and niche simply dyne into centimeter, dyne gets cancelled, centimeter cancelled, so ultimately 10 to the power 7, that is 1 joule equals to 10 to the power 7 erg, right? This is the relation between the units of work. Now we have two interesting concepts. Number one is component of displacement and number two is component of force, right? Suppose we are considering this an inclined plane, this surface which is inclined at an angle theta, right? Here is a block, as you can see. We are applying a force capital F on the block and it displaces on the inclined plane by a displacement of S, as you can see, right? So F is the applied force and S is the actual displacement of the body along this inclined plane. And what is the angle of inclination of the inclined plane? That is theta. Simple. See, at the case of calculating work done, we need to figure out whether the force, that is F, and the displacement S is at the same line, right? Force is acting in this direction, in this horizontal direction, but displacement is along the inclined line. So we must put the component of this displacement along this horizontal line, right? What I said, force is acting along this horizontal line and displacement is acting along this inclined line. So to calculate work done, we must imply force and displacement on a same line. So this S has a component which is lying on this horizontal line, that is S cos theta. The component of S along horizontal line is S cos theta. So here F and S cos theta are lying on the same line. Okay. So this is simply component of displacement because we have taken S cos theta. And what will be our expression of work done? At this case, W equals to F into S cos theta. This is the expression, right? Second is at the case of component of force. Here the body is similarly on an inclined plane of inclination theta. This is the horizontal line or base line. See, the body actually displaces from this position to this position, and we are applying force F in the horizontal line, same as this one. But we here need to calculate the component of force. Component of force matlab force will be in line with the displacement. डिफरेंस को समझो, इधर क्या था, फोर्स और ये जो डिस्प्लेसमेंट है, डिस्प्लेसमेंट फोर्स के साथ इनलाइन होगा, इसलिए हम लोगों ने डिस्प्लेसमेंट का कंपोनेंट लिया. इधर डिस्प्लेसमेंट सेम रहेगा मगर फोर्स should be in line with the displacement. That's why we will take the component of force, that is F cos theta. It is directed like this. F cos theta goes in this direction and S is in this direction. So F cos theta is along the displacement S. So here work done will be W equal to F cos theta into S. This is the expression. So from these two we can conclude one simple thing. W equals to Fs cos theta, that is F dot S. When we will learn vector in class 11, we will see that cos theta represents dot product of vector. ठीक है, अभी के लिए बस ये याद रखो, F vector dot S vector. And if two vectors are applied dot like F and S, they are multiplying using dot product, that creates scalar quantity. मतलब dot product की मदद से अगर कोई quantity create होगा, then that quantity will be a scalar quantity. ये जो force है F और ये जो displacement है S, इन दोनों का dot product होके W, that is work create हुआ. That's why work is a scalar quantity. That means it has only value but no direction. So वर्क जो है, वर्क का सिंपल एक वैल्यू होता है और उसका कोई स्पेसिफाइड डायरेक्शन नहीं होता. गॉट इट? सो दिस वन इज द कंसेप्ट ऑफ वर्क. नेक्स्ट वी विल गो टू द सेकेंड टॉपिक, दैट इज टाइप्स ऑफ वर्क. एकदम सिंपल एग्जाम्पल है. सपोज दिस इज ग्राउंड, वी आर throwing a ball at a certain height and the ball is falling from this height, say h. Right, this is the velocity of the ball. See, at the case of falling ball, earth attracts that ball due to some gravitational attraction force of the earth. So earth is attracting the ball towards the direction of its motion. That's why here positive work will be done, right? Because F is positive, force is positive, and S, that is displacement, is also positive, right? But at the case of negative work, if we are throwing a ball to upward direction. This ball has been thrown in the upward direction. So at the case of upward direction, earth will put a extra gravitational force in the opposite direction of the motion of the ball. The ball is going upward and the force is acting downward. So here this force, if this force, that is force due to gravity, is creating a negative work done because AC is negative. Force is applying in this direction, but V, that is displacement, is going in the upward direction. So there is reverse of direction, that's why a minus, right? And no work force is, suppose say displacement is 0, like if we put some amount of energy in a wall like this. I am putting some amount of energy in this wall, but the wall is not moving. So that's why if displacement is 0, then W is 0. This is an example of no work done. Second, if theta equals to 90 degree, then W equal to Fs cos 90. फॉर्मूला क्या था? Fs cos थीटा. इधर तो थीटा 90 डिग्री है और cos 90 मतलब इसका वैल्यू होता है 0. So 0. This is no work done, where at the case 1 displacement can be 0 and at the second case theta, that is angle between S and F. The angle between displacement and force is 90 degree, then we can say there will be no work done, right? So now we have our third topic, that is no work force. Here is a drawing. This is sun, right? This is earth, sun, earth, and sun is attracting earth by giving some amount of gravitational attraction force. So there is a certain force F, that is gravitational attraction force. V is the velocity of the planet, and this 90 degree is the angle between this radius and this tangent V, right? So here we can say work done, that is W equals to F, force into displacement. So here we can say Fs cos theta. F is the force, S is the displacement, and cos theta is just a multiplicative term, equals to Fs, see, cos theta. Theta means this angle. Here theta is how much? That is cos 90 degree. And what's the value of cos 90? That is 0, correct. So F is a no work force. No work force, right? So no work force is that force by which work done due to a system is 0. Here gravitational force, that is capital F, is a valid force, but work done due to that force in the case of sun and earth will be 0 because force and velocity are at 90 degree with each other. Got my point? Okay. Next we will have our topic number 4, that is power. So now power. Power is basically defined as the rate of work done, and it is expressed as P. So P equals to work done, that is W, by time, that is T. W by T, work by time, right? So what will be its units? In SI, the unit of work done is joule and time is second. So joule second inverse, it is called watt, that is capital W. And at the case of CGS, joule will be replaced by arc and second is always second, so arc second inverse. And it has another useful unit that is used in cars or basically factory purposes, which is called horsepower. Horsepower, that is HP, and we define 1 horsepower as 746 watt. So this is the relation between horsepower and watt, right? Next we will learn the relation between power and velocity. So power is P and velocity is V. We know power P equals to work by time, W by T, and work is force into displacement, that is FST, and S by T is simply V, that is average velocity. This V is average velocity. So P equals to F into V, that is power equals to force into average velocity. If we define S as distance, then this V will be average speed, right? Distance by time is speed, so V will be average speed. As we have defined S as displacement, that's why V is average velocity. So simply power is force into average velocity, right? So that's the end of lecture number 1 of the topic work, energy, power. In the second lecture, I will discuss about energy. I hope you have enjoyed this session, and if it helps, give a thumbs up, do comment, subscribe and press the bell icon and share with your friends and buddies. तो मिलते हैं अगले वीडियो में, तब तक बाय, टाटा, गुड बाय.